Hey Pre-AP, we're now starting our Unit 2 of Biochemistry. So let's start with our 2.1 outline, the chemistry of life. So make sure you have a highlighter and a pen so that as we go through this you can annotate your notes and you'll be ready for class tomorrow. So go ahead, please highlight what matter is. All matter is it's something that takes up space and has mass. Because remember, all mass is the amount of matter in an object. Alright, so also know element. What is an element? You kind of touched on this in 8th grade. It's the simplest form of a substance that cannot be broken apart. But remember, it still has properties. If we look at our example chlorine over here, chlorine is a deadly gas. It's actually this greenish yellow hue that you see inside of this flask. So make yourself this example, chlorine, Cl. That's its symbol. It's kind of like its shorthand name. It's like its initials. So, know that this is a deadly gas. They actually used this in chemical warfare. They used it first in World War I in Europe, and a lot of people died from this because it got into their lungs and it pretty much smothered them to death. So, element. Simplest form of a substance. But if you move on to compound, know that this is two or more elements bonded together. But the thing is whenever this bonds together, it results in new chemical properties. Your example is water it gives you, because hydrogen itself is a flammable gas. And oxygen is also a flammable gas, but when you bring those two elements together, they create the greatest compound on the face of the earth, water, which sustains all life. Go ahead, put you another example. This is sodium plus chlorine. This is salt. Sodium is a solid, this little guy right here. If you throw a nickel size piece of sodium into a swimming pool, it will actually blow up the bottom of the swimming pool, and there will be a gigantic hole there. It's very reactive with water. We already talked about chlorine, very dangerous, deadly, toxic gas, but when they come together, they create the greatest thing to flavor food on the face of the planet, salt. So two deadly stuff come together, actually makes something that everyone enjoys. Make sure you know chnomps. Make sure you write out beside here, somewhere on your notes, what C means. H, N, O, P, and S. Everything in biochemistry, every living thing contains all 6 of those elements. Later, whenever we talk about proteins, nucleic acids, carbohydrates, and lipids, they're all going to contain one or more of these. So subatomic particles, you know this. An atom is the smallest unit of matter. Also know your subatomic particles, like proton. Remember, proton's positive, neutron's negative, electrons are negative, neutrons are neutral. So electrons, protons, and then neutrons over here, they're neutral. Please know that for neutrons, because they're neutral, make sure that you underline that their number of neutrons, your number of neutrons over here can change. If the number of your neutrons change, we call that an isotope. Like carbon. Carbon has many forms. Carbon-12, carbon-13, carbon-14. And whenever all of those change, it changes because of the number of neutrons. If you have a different number of electrons, we call that an ion. You can be a cation, where you have a positive charge, or an anion, which you can have a negative charge. So remember, isotope goes with different number of neutrons. Ion goes with different number of electrons. Protons, go ahead and put this out there. Protons are permanent. Protons never change. Otherwise, you would change the element. We'll learn a little bit more about that when we look at your... So remember, isotopes, just like we said, different number of neutrons. There's your carbons. You might have a data set question about this tomorrow, so keep that in mind. Ions, different number of electrons. Periodic table. You need to know that as you go through the periodic table, you have different levels of potential energy. Remember, potential energy is stored energy. It's actually stored in chemical bonds, two elements that are bonded together. And remember that your atoms are weighed in something called, I don't really tell you Daltons, most of the time you hear it as atomic mass units, AMUs. Electron orbitals, we'll kind of talk about this in class because it's a lot easier if you draw these. So a molecule, please know that a molecule is two or more atoms bonded together. They may have the same type of atom or they may not. Like right here, go ahead and put you an example. Water is a molecule. H2O is a molecule. It has two hydrogens and then one oxygen. This is one where you have different atoms coming together. Periodic table, atomic number, just make sure that you know that atomic number tells you how many protons and how many electrons you have. So please highlight that. Atomic mass, that is, they also call it your atomic weight, so atomic mass. Put out beside there, it's your protons plus your neutrons. That's all it is. If you have the atomic mass and you don't have how many neutrons, subtract the protons and you can find the neutrons. So, any time that you look at an element on the periodic table, know that 8, that's your atomic number. Remember, atomic number means your protons. Usually it means your electrons too. Remember, this is your symbol, like the initial. Oxygen is the name. And then this guy is your atomic mass. Your protons plus your neutrons. So if I wanted to find out, I have my protons. All I'd have to do is take my atomic mass minus my protons, and I would get relatively about so and so many neutrons. I don't have my calculator with me, but just showing you. Atomic mass minus protons gives you your neutrons. We're going to do that as math tomorrow. So radioactive isotopes, those are isotopes that can actually be very harmful for you. Please know in your outline, this is the different number of neutrons. And because they have a different number of neutrons, they have the same chemical properties the normal element has, but the physical properties, what you're looking at, may be different. Most isotopes are radioactive. So it's kind of like that song, Radioactive by Imagine Dragons. We're going to talk about this chart tomorrow, so do not be worried. If you want to go ahead and write this on your lovely periodic table so you'll be ready tomorrow, please do that. So on to part 2, flip it on to the back. Remember, potential energy is energy of position. go ahead and write out beside this that you are standing still if you're a person. But if we look at the picture, who has more potential energy? I hope you say this one. This one doesn't have a long way to fall. This one does. She's got way more energy stored up here. But if you are elements, you are usually locked into a chemical bond. That's why you have potential energy. Whenever that bond is broken, you release chemical energy, energy of movement. Alright, so we're going to finish this tomorrow. Go ahead and read through the rest of your outline and highlight the rest of what is important. It will not be hard to find out what's important. And I will see you tomorrow.